Right, in this SD-WAN class, if you remember previously, if I go a little bit back from this slide, we were seeing that there are segments. Segments are nothing but VPNs. And to identify the VPN, we have VPN number. VPN number 0 is for bringing up the tunnel for the transport VPN. And VPN 512 is only for management. Yep, VLAN 512 is only for management. And the rest of the VPN numbers, you can use it for service. So you can use numbers from VPN number 1 till 511 and from 511 to 65,000 plus. So we also learned that the VPNs that are between the provider edges, between the, sorry, what I'm saying, not provider edge, the WAN edges, between the WAN edges, the VPN that is between the WAN edge and the controller, they're all called as transport VPNs. And the VPNs that is towards the LAN side, the VPN that starts from the LAN side, from the WAN edge to the remote WAN edge, LAN side. The tunnel that is going to carry the LAN traffic between the WAN edges are called a service VPN. You may have many customers. For each customer, you may have different policy. We can also tie those routing policy to the VPN. Now, from here only we need to start. So on the edge router, only the SD-WAN uh, creates VPNs. SD-WAN is same like RFC 4023. What does it mean? Same like RFC 4023. That talks about MPLS layer 3 VPN. If you one minute. Yeah, correct. It is same like the encapsulation of MPLS in IP or GRE. What MPLS will provide? A label for the service traffic. An underlay is also going to be an MPLS. Overlay is also going to be an MPLS. I'm trying to relate SD-WAN with MPLS layer 3 VPN. If you recall, in MPLS there are two layers. In IP, in the packet, you will have two MPLS layers. In layer 3 MPLS VPN, there are two MPLS layers. One layer is to identify the remote tunnel endpoint. The other one is to move the packet towards the tunnel endpoint. Similar to that, we have VPN ID. VPN ID is same like the VPN label is same like MPLS label. And now um, this label is different for different traffics. So the traffics, they don't get mixed; they are isolated over all transport. What does it mean over all transport? We may have MPLS as underlay. We may have internet, whatever the path you take. The VPN that is going to be as an overlay still maintains the isolation of traffics between the WAN edges. So you no need to create a separate transport tunnel for each VPN on the WAN edges. It's exactly same like what we have in MPLS layer 3 VPN. There's going to be a separate VPN label added to the part of the label stack over the same transport. So what it is needed here is the VPN ID. That is very important. You see, all the edge routers are advertising their VPN IDs using OMP to the vSmart. Understand? The VPN ID is the key here. The segment ID, the VPN ID. This VPN ID is advertised to vSmart. Each WAN edge advertises the VPN ID to the vSmart, and vSmart distributes to other WAN edges. So now, WAN edge in the left, let me call it as WAN edge 2. WAN edge 2 knows the WAN edge 2 knows the WAN edge 1 as the remote tunnel endpoint because the VPN ID matches. And vSmart distributes it. WAN edges will advertise only to vSmart using OMP as OMP update. So labels are used in OMP router attributes and in the packet encapsulation, which identifies the VPN the packet belongs to. You can see that here. This is the tunnel, but there is a traffic isolation. VPN 1 and VPN 2, they never get mixed. Like we used to have in layer 3 VPN, a separate label for each customer. There's the service label, same like that. And if you see here, this is very important to understand. If you don't understand this, then you will not know the sequence. This is our data, the VPN ID, the IPsec to provide security between the WAN edge. The traffics are IPsec, IK encrypted, and then comes the UDP and then the IP to move the packet from one WAN edge to the another WAN edge. So with the help of this, it goes from one WAN edge to the other WAN edge, and on the remote WAN edge, the decapsulation happens and it reads the VPN ID. If the VPN ID is 1, then it pushes to the member of VPN1. If the incoming VPN ID is 2, it pushes the packet to the member of VPN2. So that is how VPN2 member in this site talks to the remote site VPN2 member. They don't crisscross, they don't mix, they're isolated. But these VPN IDs are not generated by ISP router. In MPLS, these VPN IDs, we call it as labels, they are generated by PE routers. Whereas here, the VPN IDs are generated on the WAN edges and they're advertised to vSmart. vSmart, like BGP route reflector, they reflect it to the other WAN edges. So I just finished saying that it's the VPN number that helps to keep the traffic separate. Now, forming VPN can be with the remote VPN of, see, here it is VPN2, here also VPN2. There is also an option to form VPN tunnel between VPN1 and VPN2. It is also possible using redirect command, but mostly it will be only between VPN numbers, same VPN numbers. Now, OMP is the one which distributes this information from WAN edge to the vSmart. At last, the TLOG is established. We already learned what TLOG is. It's an abstraction to the underlay. TLOGs are between the boundaries of underlay and overlay. So the Cisco SD-WAN has underlay and overlay. TLOGs are between the boundaries of underlay and overlay. These TLOGs act as a tunnel endpoint and as the next hop. Yep, it's a tunnel endpoint, meaning it provides the next hop. TLOG is an abstraction layer for defining the IPsec tunnel endpoints when you form an overlay fabric. Even though it acts as an abstract, it is the tunnel endpoint that's very important. It is a tunnel endpoint. It provides the next hop. Now, this TLOG consists of a key value pair. The system IP address of OIMP speaker. System IP. So that shows from where this OMP is originating. The system IP in the TLOG. TLOG carries this information like VPN ID, system ID. So system ID in the TLOG shows who has sent this VPN ID. Who is the OMP speaker? Right, so the TLOGs are advertised to vSmart control. Now, key pairs, so more about this key pair. It has got a system IP. I just finished saying what is system IP. System IP address of OMP speaker shows from where the OMP originates. OMP roots are originating. Next, the color. Color defines which type of link to use to communicate between the WAN edge. In order to create this overlay, the system IP says I'm coming from this particular WAN edge. Color says I want an MPLS link type, or I want the IP link type, something like that. You have different type of WAN connection. Color defines the link type, and then encapsulation type. So these are the three pieces of information that is there in the T-log. And this is what used to define IPsec tunnel termination point. These three things, right? So how do T-log get know the SD-WAN network? The WAN edge routers will advertise its T-log to the vSmart controller. I'm just trying to summarize how SD-WAN network gets this T-log. The WAN edge routers advertises to the vSmart controller, and vSmart controller distributes it. And again, there is no policy by default, but if there is a policy that restricts forming tunnel with one particular T-log, then vSmart controller will not advertise it. So T-logs may be bringing a lot of VPN IDs from one WAN edge to the other means one WAN edge to the vSmart, but allowing two WAN edge to form tunnel depends on the policy. If you don't write policy, then tunnel will be established. This VPN 2 and VPN 2, VPN 1 and VPN tunnel will be established. But if you will have a policy, by default there is no policy restricting uh, forming tunnel, but you can write a policy that will make vSmart to distribute only those T-logs that are really necessary. Other T-logs will be filtered. So if you don't have policies, vSmart controller will simply reflect the T-logs to other WAN edge routers. As I already mentioned, vSmart controller acts like an intelligent route reflector, and the VPNs are going to be established. See, T-logs are advertised to vSmart. T-logs carry what? Where VPN ID, and then key pair like system ID, and then the encryption, and then the color. Accordingly, the T-logs are advertised to vSmart, and vSmart distributes it like a route reflector if there is no policy stopping. If there will be a policy not allowing WAN edge to form tunnel, then it will stop. So T-logs are viewed as the data plane set of information using which the tunnels are created between the WAN edge. Also, this T-log is serving as a next hop uh, for the route advertisements. So if you are filtering some T-logs here, then you can you can deny forming tunnels. Now, something very important um, to understand about how this T-log is helping us, or how the T-log is working. There is something called R locator, which you might have learned in Lisp topic. There's a concept called Lisp. This is not SD-WAN. I'm trying to first, quickly teach you that Lisp and then bring you to SD-WAN. Let's say this is one site. Don't think it as manage. One site, London. This is another site, Dubai. Now London router don't have any routes to Dubai. Likewise, Dubai router don't have any routes to London. These are all called as EIDs, Edge IDs. They will have an Edge ID. Edge ID. Now, there will be a Lisp database router in the internet cloud, which will have the mapping of EID and the IP address, which we called as remote locator. For example, here Dubai's IP address and the edge ID and the address to reach the edge ID will be maintained in this database or log database somewhere in the cloud. So this database will know all the locations, edge ID, and the RLOC means remote location ID means the IP address. So now, if London wants to go to Dubai's network, all that it needs to know is the database. It goes to the database and ask, fine, how can I go to this Dubai Edge ID? Then, like a DNS, it resolves and says, this is the IP address, this is the destination you need to go, and this is the route. Who gives this? This database will give the route. Using the route, it will go and talk. Exactly same like that we have a vSmart. vSmart is a database that has got all the T-log informations, all the VPNs on all WAN edges. If one WAN edge wants to communicate to the remote WAN edge, it receives the RLOC information or it receives the T-log information here. We don't call RLOC. RLOC we call RLOC in Lisp. Here we call T-log. So the T-log information with the physical next hop is provided by the vSmart. Using the next hop, one WAN edge can establish VPN with the other WAN edge. That is why I said it is like vSmarts are providing data plane information. In T-log is seen as the data plane set of information and which is distributed by the vSmart. Fine. Next is the color. All right, we have already discussed on all these things. And this is also this is what Lisp, which I talked about. I see the edge ID, the remote locator address. So remote locator address is pointing towards Edge ID, the database, using which even though you don't have a route, you can learn routes through the Lisp database and move the packet. Same like that we have vSmart. Next is color. Color defines which link to take. Should I take a private link or a public link, or what sort of link? Is it an IP routing path or a MPLS label switching path? Is any color natting involved? There is a separate color for nat, you know. So there are a lot of predefined colors like Metro Ethernet is one color, Ethernet is another color, MPLS is one color, private 1, private 2, private 3, private 4, private 5. These are all considered as a color. So the color helps to identify the path, the link to take, and TLOG helps to identify the next stop. So now there are more colors like 3G, BIS, Internet, public color, and so on. Each T-log in a specific color will connect to remote T-log in the same color, or as I said earlier, you can also form tunnel with a different color. Same color is what by default, but you can also establish VPN with different color. So if you are using a private color, then we will be using a private address. So one thing I want to quickly remind you that data plane tunnels can be established across different color as long as there is a reachability between the T-locks. Very important. If you have reachability, then you can establish tunnels between different color. Yeah, exactly. This is what we just finished talking. You can limit this connectivity to shape the network a little bit by using the keyword restrict. So you can use the keyword restrict to deny one color forming tunnel with another color. You can use the restrict keyword. Next is BFD. Using BFD only, we have the live statistics of our transport, the jitter, the delay, the bandwidth. The performance is measured using BFD. Time to time, BFD uh, provides the information of each link using which SD-WAN can take the best path, pick a best path. So the BFD probes are the reason behind knowing the best path to reach the remote T-lock next stop, right? So periodically it is sent. So OMP protocol uh, is the reason for all the distribution of routing information. This is a very familiar topic we have already seen many times. Now, here the important thing where I want to go is vroute and all we saw earlier class. If you see, you'll see all those things. Yeah, this is where something new comes. You see, you may have one server to reach which is active, and the other server to reach as a backup in SD-WAN. So the server in DC1 is an active server, the server in DC2 is a backup server. But how SD-WAN knows that I need to go to DC1 first? Only if DC1 is unreachable. Only when the server in DC1 is unreachable, I need to use DC2. How? How SD-WAN segment knows it? By prioritization. That's what this topic is about. OMP can be prioritized. The OMP updates, no, you can prioritize. Bigger number is better. The higher is, bigger is better. The higher is preferred. You can set the preference value high for this data center so that the servers will have same IP address. Say for example, DNS server, 8.8.8.8. But the DNS server has got the same, even though they have the same IP address, there are different sites in different data center. But whenever someone wants to reach this DNS, I'm just taking DNS as an example, it may be a mail server or anything. If someone wants to reach this server, they are only directed to data center 1 because data center 1 has got a high preference value. When you configure, you put high preference value to the data center like this. You see, address is same on both the data center. Address is same, but data center once ad, uh, uh, is next stop is preferable. That T-log is preferable because of the preference. So in the routing table, if you check, to reach this network, you will have only the root with the next hop DC1. So OMPs are distributed through vSmart. These OMPs can be prioritized using preference. Right? So we have seen a lot of things about SD-WAN in very deep depth. We saw all the components of SD-WAN, all the controllers of SD-WAN, the protocols, and how the routes are distributed, and so on. What is left in SD-WAN is the demo. Take some time.